Looks like we are in. Hi everybody, welcome to today's session of UPSC Buffet by Gallant IAS. So today we'll be discussing the 2024 questions from the geography part of 2024 questions. And I hope you are following the previous sessions on 2022, 21, 22, 23 so far. And I'll give you an overview of this particular paper right away. Because this is one of those years where geography took the center stage, where a lot of questions has been asked, so primarily from the conceptual side of things, and they were entirely based on the PYQs itself. As in, you could easily get 3 to 4 questions right away from the PYQs from 2021 to 2025. So that is such a easy and rewarding thing for those who have been working on their PYQs. So we can expect such questions and such sort of questions in the coming years as well. Even 2025 was an extension of 2024 itself. And also on a larger scale, the question has been very much different because UPSC did away with the making the entire options as only one, only two, and they have moved on with the usual the elimination possible kind of question setting. So that was a welcome change because UPSC itself found out that making everything strictly factual was not the way to go. So they kind of toned it down, and it was even more toned down in 2025. So but there are few insights that the fact side of things should be very clear, that we should be having enough facts so that even the questions of only one, only two repeats, we should be able to answer them. So without any further ado, let's get started. So the first one, like I always say, favorite area of UPSC, insulation and atmosphere. The atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Interesting. Carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. If you have been following the class for the last few days, you actually know the answer. And right off the bat, this is the first question. Atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Is it so? What's the major cause of global warming? Is it the sunlight that is coming, or the trapping of heat that is being re-released by the earth? What's the cause of that? So atmospheric warming is called global warming, and is sunlight the root cause of that? We know that it's not, because sunlight has always been constant, and sunlight, the atmosphere more or less acts like a transparent channel for the sun insolation to come in, except for the low clouds which deflects the sunlight a bit due to their albedo. But other than that, most of the atmosphere is straight away. It acts like a clean slate for sunlight to come in, and that is not heating the atmosphere. The ultraviolet, short wave, high energy waves are not the ones eating it. These rays, upon hitting the earth acts like a black body, like I always say. It absorbs the radiation and then it re-emits the radiation. And any black body radiation that is re-emitted will be always in the long wave spectrum, and it will be having long waves, and it will be in the infrared spectrum. Okay, so we knew all of this from PYQs on itself. Like, I haven't read the entire thing from NCRT or anything. It's entirely PYQ knowledge. So atmosphere is heated by incoming solar radiation than by terrestrial radiation. It's an obviously wrong statement. It's the other way around. Atmosphere is heated by terrestrial radiation than solar radiation, because solar radiation is high frequency short waves with which the atmosphere acts like a transparent surface. It doesn't hold or it doesn't absorb those things. So that's wrong, and I think since it's a statement question, we already got the answer. But looking at the second statement, carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long wave radiation. This is exactly why we are having global warming, and greenhouse gases like carbon dioxide and even water vapor is a contributor to increased global warming. Water vapor is also a greenhouse gas. That has meaning that it will absorb the terrestrial radiation, which is in the form of long wave radiation or infrared radiation. Okay, so that's it, and this is a right statement. But in this question, we didn't really have to know that. Just the first statement, eliminating first statement itself, will give us the answer. So that's it. Moving on. Again, another question. Thickness of troposphere at the equator is much greater compared to the poles. Okay, at the equator, heat is transported to great heights by strong convectional current. Start off by, I really hope everybody knows what's troposphere. Troposphere is the first layer of atmosphere looking from Earth, and then it's followed by stratosphere, mesosphere, thermosphere, and exosphere. So That troposphere is the lowest point in atmosphere, extending up to 10 to 14 kilometers. So that's the layer of atmosphere that is closest to the earth. So thickness of troposphere at equator is much greater as compared to the poles, meaning that if we are drawing a line like this and earth being something like this, and if this is the troposphere, along the poles the troposphere will actually be having, along the equator it will be having a higher altitude, and as it approaches the poles it will be having a decrease. This is in the poles. Okay, so that's the case. They are saying that if you don't know anything and you know that troposphere has got a variation, it could vary from 10 to 14 kilometers. There is a variation there. So if you can imagine that in the equator where there is frequent rising air in the form of convection current, this can actually push the troposphere up to a certain level at 2 to 3 kilometers, and lack of that can actually pull it down or keep it like normal, is in the case of poles. Why? Because some sort of energy is needed, and to initiate the strong convection current. Convection current means just rising air. To induce the rising of air, we need to put in some energy, and that energy is coming from the sunlight, solar radiation itself, and it's maximum at the equator and it's minimum at the poles. Thus the troposphere will have a minimum height, minimum altitude at the poles, and will have maximum height at the equator. So that's true. This is right, and this statement is right, and this is exactly the reason for that statement. So that's it. It's very straightforward. I think it's given. I made a chart just for your reference. It's thickest at equatorial region with 16 to 18 kilometers, and you can observe a declining trend of troposphere, meaning that going to the tropics, it's going down by 2 kilometers. A delta of 2 kilometers is there between each latitudes, tropics, mid latitudes, polar region. So that's it. And reason is warm air expanding lighter and rises above. Strong convection current, tropopause upward. Yeah. Weak convection current, meaning that the height will be less. Then so cold air contracts, becoming dense, and it's lower. So that's the effect that's happening. It's very basic, and it's very you can easily picture it, and that's it. You don't need to study anything much more than this. Remembering this number helps. I wouldn't say learn the exact figures, but 10 to 14 kilometers is the height of troposphere. Having that idea actually helps, as in what's the kind of altitude we are talking about, and in which altitude does the flights fly, or in which altitude or which layer of atmosphere where the fighter jets fly. So having that idea really helps. Okay, so just keep that in mind. Okay, how many of the above are products of volcanic eruptions? Pyroclastic debris, ash and dust, nitrogen compound, sulfur compounds. For questions like these, think about elimination is the way to go. Okay, try to eliminate whichever things possible and arrive at the answer. You actually, in NCERT, exact statement is given and that is there, but you don't need to know any of that for answering this question, because we are trying to eliminate it. Okay, in a volcanic eruption, that is the hot magma that is being stored in the mantle, it's erupting, and it's even recently in Ethiopian volcanic eruption, you could feel that, like, the kind of compounds it releases. Deep inside the earth, we have got assortment of, in fact, almost all the compounds in varying quantities. So in such a scenario, an eruption occurs, and won't there be ash and dust? Obviously there will be nitrogen compounds. Nitrogen is present in the atmosphere, and nitrogenous compounds will always be there in the mantle, no doubt for that. Sulfur, obviously, and that has been one of the large reasons for this recent Ethiopian earthquake and subsequent blocking of flight paths, things like that. So we could easily add this. And if you know what pyroclastic debris, or if you know that, as in deciphering the name, pyroclastic means something that is arising out of fire or explosion or something related to fire. So pyroclastic debris, nothing specific is given. Pyroclastic debris, like if you just ignite a fire on a paper or a wood, it will be radiating some sort of debris here and there. Those are called pyroclastic debris. That's basic for any sort of burning, and it's there, it should be there, and it's there. There is no way we could eliminate any of these. So answer is D. This exact statement is given in NCRT, but to solve this question, you don't need to know all that. And don't make the mistake of actually, considering everything as right in questions like this. You should actually put in some effort on trying to eliminate, and if you can't eliminate, then go for it. Don't straight away think like, okay, everything will be there, all four. No, that's not the right approach, because certain things can be given here, which can make this question go wrong. So you should be giving your due time and attention to the question and try to eliminate. And if you are not able to eliminate, go for the all four. That's it. Okay, which of the following are correct inferences from isothermal maps in the month of January? See, this question, the same exact question, slightly in a different way, was asked in 2023, just 1 year before. And I've showed you the map also, the isothermal maps of month January and July. It's in the NCERT itself. The only thing to notice is that isotherms will bend. There is a bend towards the north around the oceans, or towards the north in the oceans and towards the south in the continents. And that is normal everywhere, but it's more pronounced in the month of January. Okay. Isotherms deviate to the north over the ocean and to south over the continent. Okay. So that's the thing that we should be looking at. Isotherms deviate to the north over the ocean and to the south and the continent. Are they doing that? Of course, they will be doing that, because continents are more cooler, and they get more cooler or more warmer depending on the temperature compared to the oceans. So there will be a deviation towards north and south based on the months, or cooler or summer or winter months, and that's exactly is given here. So they deviate towards the north over the ocean and towards the south. Yeah, that's true. That's the correct answer. And presence of cold ocean currents that are Gulf Stream and North Atlantic drift make the North Atlantic Ocean colder, and isotherms bends towards the north. Is it so? Bending of isotherms towards the north, meaning that it's warmer actually. Okay, so they are holding a warmer temperature, and to induce a warmer temperature, we need warm ocean currents. And one more very obvious thing is that Gulf Stream, North Atlantic Oceans are not. That's not because of cold oceans. Okay, it's because of their warm oceans only. It's given like the presence of cold ocean currents, Gulf Stream and North Atlantic Drift. We cannot completely say that whether they mean Gulf Stream and North Atlantic Drift are cold ocean currents. They are just saying presence of cold ocean currents, Gulf Stream and North Atlantic Drift. The answer is presence of warm ocean currents. Gulf Stream and North Atlantic Drift are warm ocean currents, but they are not saying that explicitly, but this is wrong. That's the key. Okay. The reason why isotherms bend north is because of the warm ocean currents. So this is wrong. I think you understand the concept. See, imagine this is 30 degree Celsius. Okay. This is a 30 degree Celsius isotherm, as in 20 degree. Okay. So every point in this line in the land and sea will be having 20 degree Celsius. That's the whole idea. And this 20 degree Celsius, when it approaches the land, it's like this. But the ocean, imagine that the same ocean in a higher latitude holds this temperature. You get the point? Meaning that this is even warmer, or the line actually parallel to it is even warmer. Okay, so that means the ocean water will hold its energy as in the form of temperature, even to a greater heights, to a lower latitude. Ideally, this 20 degree Celsius should have been felt in, say, like latitudes of 20 degrees Celsius, 20 degree north. But due to the specific difference of water and land, this same 20 degree can be felt at an even lower, at an even higher latitude. So that's the thing. Meaning that even a region is colder, but the ocean will be warmer. Okay, because it can hold the energy for a longer period of time. So that's it. That's the basic idea. These are isotherms, and isotherms is an imaginary line connecting the regions having same temperature. That's it. So any point in this line, whether it is here or here, will be 20 degrees Celsius. That's the whole idea. And this is very important. Just try to study about this cold and warm ocean currents. It's very easy if you find the pattern there, because there is an alternating pattern. In the eastern coast, it will be warm ocean currents. In the western margins of the ocean, there will be cold ocean currents. So western margin, eastern margin will be warm, except for Australia. There will be warm and ocean currents alternating from west and east. Okay, so the western margins of the oceans will be having warm ocean currents, and that's one reason we are having desert-like phenomena in the western margins of the continent, and they are relatively warmer also. They are relatively drier, not warmer. They are relatively drier because these cold ocean currents acts like a inhibitor for precipitation. The conditions the cold oceans prevail makes the situation, makes the regions adjacent to it arid, drier. On the other hand, warm ocean currents can bring in rainfall. So that's the thing, and that's one basic thing. Then cold ocean currents will be moving from the pole towards the equator, and the warm ocean currents will be moving from the equator towards the pole. So you will get the direction also. Now first you get the location, then you get the direction, then you study the names, and that's it. And very important to notice is this combination of Oyashio-Kuroshio current. Oyashio coming from the pole, meaning pole towards equator, meaning it's cold. Kuroshio going from the equator to the pole, meaning it's warm. And this is one of the largest or one of the famous fishing grounds in the world where good quality fishes are there. And then this is another thing, Gulf Stream. See, this is a warm ocean current, and that Gulf Stream actually shifts into two. North Atlantic drift, as in it shifts into two, and this particular effect is the reason why the ports in the North Sea remain operational even during winters, because even when the entire ocean and everything is ice cold, this warm ocean current in the form of Gulf Stream travels towards those regions, as in the regions of UK, like the North Sea region. So that's very important for the maritime sector. The ports like Rotterdam, they all remain operational because of the warm water brought in by the Gulf Stream. Okay, the entire ocean is cold, but this Gulf Stream, the particular stream of particular ocean current brings in the warm air, and they actually facilitate operation of ports. That's a very interesting phenomenon, to be honest. Then that's a basic thing. Study it like that, and then there is equatorial current and equatorial counter current. Okay, that means polar. Assuming this area, there will be cold ocean current coming towards the equator, and then there is this eastern Australian current coming away from the equator. It's a warm current. So what happens to this current? Once this cold current with cold water reaches the equator, equatorial region is warm. This region is entirely warm, heated up by the sunlight. So it will be moving in this direction because of Coriolis force, and it will eventually reach a point. Okay, it will be going like this, and at a later point they become a warm current like eastern Australian current and flow towards this. In a way, they create a independent circular paths around these places. See, there is an independent anticyclonic circulation, anti-clockwise rotation in the southern hemisphere, and here a clockwise rotation, but the same phenomena. So these, once they join here, they forms the equatorial current, and the location is based on which half of the hemisphere they are in. Southern equatorial current means southern hemisphere, northern equatorial current means northern equatorial, and these two under the influence of trade winds, they actually move towards this side and accumulate and creates a pressure gradient. It's just like we are accumulating water in a particular area, and due to the trade winds are continuously blowing, and this accumulated water actually releases in the opposite direction, as in water is been accumulated to one place, and then it's actually causing a potential gradient, as in the height of the water is higher, so the water will start flowing in the opposite direction. It's like we are pushing water away to a corner, and because of that accumulation of water flows back into the opposite direction. That is equatorial counter current. So that's it. That's the basic idea, basic mechanism behind the entire currents, and just study that their direction, their names, and whether they are warm or cold. That's it. And to make it very simple, just picturize them. If they are on the left side, or if they are going towards the equator, cold. They are coming away from the equator, warm. That's it. And this is very important. The direction of Gulf Stream, and this is very important because there is a slight drift happening. As in this, it diverges into two. There is a forking happening, and that's it. So that's all. And there are some smaller currents like Somali current, Agulhas current, and other small currents are there. Then there is west wind drift fueled by the westerlies. So you have to bring in that also. In those latitudes where the direction of prevailing winds, whether it's trade winds, northeast trade winds or southeast trade winds, the currents will be following that direction. Okay, and they all follow that direction because of the Coriolis force only. And if it's in the westerlies, the currents will be having that direction, the westerly direction. And in the polar sphere also, there will be polar easterly direction. So that's it. Overlay the currents with the prevailing winds so as to get the idea as to why they move in certain directions. Okay, that's the reason. Moving on. I hope you understood that, but no problem. Even if you are having any issues or difficulty in understanding concepts like these, we'll be conducting a masterclass on these topics later. Okay, so stick to the channel and we'll be doing that. Moving on. Which one of the following countries are well known as the two largest cocoa producers in the world? Okay, this is not something that we usually study. If some people have come across it in some current affairs, it's good only, but I don't think this is something that everybody knows. But this can be done. This can be actually logically cracked, because luckily in Kerala we know, or if you have a picture of cocoa, what kind of crop is that, or what's the kind of impression that you get? Is it a crop that is being grown in a dry region like the dates, or is it a crop that has been grown in in a very rainy or wet conditions? What's the kind of idea you are getting? If you have seen cocoa, you will know. If you have seen ads of cocoa, you know it's basically used for making chocolates. So you all know that it's not a dry crop. It's found in areas of abundant rainfall. So that's the first thing and the biggest clue we have. So cocoa, high rainfall. Rainfall is high. Rainfall requirement is there. I don't know the exact number, but they grow as a plantation crop, and plantation crops in general need high rainfall. So Algeria and Morocco, less chance. They will be maybe this. And imagine, okay, one more thing I'll ask you. Algeria and Morocco, what kind of crop will be best suited for this climate? It will be either dates or olives, something that is growing on arid areas, not cocoa. So that's gone. Botswana and Namibia, we know that. I yesterday told you, like, learning the map of Africa really helps. Africa has got, majorly 4 regions. First the Sahara region, then the Sahel region, then the equatorial region, and then the sub-equatorial region, subtropical region. Botswana belongs to the sub-equatorial region, where there is very less rainfall, but not like a desert-like structure, like the northern Africa. But there is very little rainfall compared to the countries above it, or just north through it. Those forms the equatorial rainforest region. So they are not the ones. Gone. Ivory Coast and Ghana. Ivory Coast and Ghana, they are somewhat in the central side of Africa, and central side of Africa has got this equatorial forest and the equatorial climate, which means they will be getting ample rainfall, no doubt about that. Then Madagascar and Mozambique. Madagascar and Mozambique, they do get rainfall, but they are not as abundant as the equatorial region. So the Madagascar and Mozambique are further south down the line, so I could eliminate that also. Just basic knowledge about the map and connecting it with the rainfall is all it takes to arrive at the answer. You don't need anything more, but you need to have an idea about that. If you see a crop, you have to picturize it, you attribute some qualities to it, whether it's a water guzzling crop or a dry crop, and just use that logic in other areas also. As in, I compared that with the map of Africa. That's why I said, knowing the regions of Africa really helps. The southern region, or whether it's in the equatorial region, or whether it's in the Saharan region or sub-Saharan region, that really helps. And Sahel region also I told you yesterday. And it's important to remember the countries in the Sahel region, because questions could be asked about that. And unlike the Levant question will be like fairly factual. As in, they will be giving number of countries and you have to be asked to choose between that. So it's going to get slightly tricky. So learn about that. Africa is very important. Learn Africa's map and the regions of Africa, as in Saharan region, sub-Saharan region, then the equatorial region, and the subtropical region. So moving on, this is strictly factual, and to be honest, I'll admit that I'm fairly poor about marking and understanding the course of these rivers, especially their tributaries. Other than the famous ones, I don't really remember much. But few things with doing questions, we eventually acquire few things, like few accumulated knowledge. that I know that Gandak is not the easternmost, and Kosi is the one that is mostly, or is the best candidate for being the east one, because this name Gomadi, Gagra, Gandak, there is a flow to it, and eventually something we end up in Kosi, and I that's how I have come across in test series and all. So I know that Kosi will be the one in last, not Gandak. Gandak is somewhere, either it's the first or the second, I don't know exactly, but Kosi should be the last, and so that I could eliminate both. Now I have to choose between whether it's Gagra, Gandak, Gagra, Gomadi, Gandak, Kosi, or Gomadi, Gagra, Gandak. Meaning that Gandak is somewhat in the same position, so I don't have to think about that. Whether I have the choice is between Gagra or Gomadi. The only thing I knew was Gagra was before Gandak. So if Gagra was before Gandak, and I don't know where to place Gomadi, it could be either way. But I think because Gagra and Gandak, that's something we usually say, when we study and when we see the papers. That's like Gagra, Gandak, Kosi. Okay, that's the kind of pattern we have. I don't know where to place Gomadi, but if Gomadi is here, I could be wrong. But if Gomadi is not there, I could be right. But from what I've heard, the only fact I know was Kosi would be the easternmost in this list. But and Gagra, and like two facts I know. The Kosi will be the one in the last. Then Gandak will be after Gagra. Okay, and I don't remember any river in between Gagra and Gandak. There will be river, but that's not. There is no something I don't remember like that. That's why I'll be going with B with that slightly higher risk, because only thing I could know was Kosi and this Gagra, Gandak. The location of Gomti is something I don't know. So it could come here or here, but I'm taking a calculated risk, seeing that I have never heard of a river in between Gagra and Gandak, like a major tributary. Of course, there will be rivers, but any major tributary in between that. So there is a good chance that there is nothing in between that. And Gomti seems to be a very important tributary also. So I'll choose B. That's how I arrive at a 50-50, then move on and choose the answer. It's not straightforward. There is an element of risk to it, and I don't recommend attempting this question. If you have enough attempts or targeted attempts are met, then no need to attempt this question if you don't know it factually, because it's slightly on the riskier side. This is actual thing. It's Ramganga, then Gomti, then Kali, Gagara. Yeah, there is Rapti in between Gagra and Gandak. Yeah, that's what I'm saying. So I thought there is no major river, but actually Rapti is the one in between Gagra and Gandak, then Bagmati and Kosi. Okay, then there is Buri, Gandak, Bagmati and Kosi. Just learn about this and yeah, be done with it. It's very factual. I don't know, even I don't know how to study. So just try to put in the effort, but I don't think you should be studying about every river and its tributaries, its direction. The reward is less. Pay your attention towards some more conceptual side of things, like atmospheric heating, ocean currents. Those sort of things are actually very rewarding, because two questions from the same concept could be asked every year, and a lot of things are repeated also. So there is high chance of making that question right. Even if you studied this and slightly forgot something or got confused between these two, the chances of you and somebody who doesn't even know anything are same only. So don't end up in that situation. If you're learning it, learn it properly, but don't spend too much time, and not spend time at a cost of not learning the conceptual side of things. Pay more attention to that, and they have a good chance of making you clear this exam, because those who actually prepare well, they know that those kind of things, or the veterans, they usually cover those areas rather than these. So that's it. Moving on. Rainfall is one of the reasons for weathering of rocks. Okay, rainwater contains carbon dioxide in solution. Rainfall is one of the reasons for weathering of rocks. Okay, both 1 and 2 statements, both of them explain. Okay, there is no point in actually. This is a right statement only. We have to consider the explanation of these two statements. Okay, rainfall is one of the reasons for weathering of rock. Right only, but we don't have to check the correctness of it. It's right. We have to find the correctness and connection of these two with this. Okay, rainwater contains carbon dioxide in solution. Yeah, obviously rainwater will contain carbon dioxide in solution. There will be atmospheric carbon dioxide, and it can actually get mixed with rainwater. The same way, the ocean is the largest carbon sink, because atmospheric carbon dioxide will actually dissolve in water, and it could be stored as dissolved carbon dioxide. So that's it. That's possible. So that's true only. Rainwater contains atmospheric oxygen. Okay, atmospheric oxygen. What's the point? Atmospheric oxygen. What does atmospheric oxygen do? Atmospheric oxygen can do few things. It can make oxides, and just like in iron that is getting rusted is because it reacts with the atmospheric moisture and it forms iron oxide. So that's the reason weathering and breaking apart of that iron material could happen. Similarly, it could happen with the rocks also. Rocks containing any metallic deposits, any mineral deposits or metallic deposits that reacts with the oxygen, and they can form oxides, and thus it can cause disintegration, weathering. So I think both the statements are correct and both of them explain statement 1. I'll go with A. Okay, so that's my logic on that matter. Moving on. Next question. Again, strictly factual. From now on, I will be asking you to study almost all the C's, because this is no way we can be doing any elimination or anything. Few things we could learn, as in when you learn map, find the countries which are landlocked. So if they are there, eliminate that. Other than that, you have to study it. If any ocean that is in news or any sea, North Sea was not that much in news, but still try to study almost all the seas. Okay, Mediterranean, Red Sea, Baltic Sea, then Gulf of Mexico, because those are all in news. Then Arctic Circle, things like that. Okay, study about that. There is no particular logic we could use here. It's strictly map based, so you have to look at the answer and find it. Like we have UK, obviously. North Sea is that's, if there is UK, no UK. So that's why Germany is also there. And the whole World War II scenario happened between UK and Germany through this. And there is this Dunkirk, that the evacuation of British soldiers happened in Dunkirk. So those things happened, but that's not enough for you to actually decipher this thing. So that's it. The answer, I think it's Finland and Norway. I think only Norway shares a border and not Finland. And then Germany is there. Finland, Germany, and I don't think Norway is there. Norway. There is no Finland actually. It's Germany, Norway. So only 2, I think. So that's the only 2. No Germany, no Russia, no Finland. So that's the answer. Strictly a map question. You have to, if you know, otherwise leave the question, it's fine. Okay, this is a fairly simple topic actually, but the way they have structured it is making it slightly complicated. Central Asia, the region. So we have to check whether this mountain is in Central Asia, and we have to check whether it's fault mountain. So there are 2 conditions to check for. That's the only tricky part here, because you might have heard about almost all the mountain ranges, but you might not know whether they are fold or block mountains, and you might not know their exact location. So that's the slightly tricky part, but we can approach this actually. Most of the major mountains that we hear are fold mountains, because they're all large and they are formed by the movement of the plate or the destructive plate boundaries when they both hit each other. One plate hitting the other plate, causing the rising of the land and the deposit sediments, whatever that is in between, and they are forming the fold mountains. This includes Himalayas, Andes, Alps, and almost all the major mountains, Appalachians, Rockies, are mainly formed by fold mountain action only. That is subduction or the plate convergence of plate boundaries. So that's the basic thing. So Appalachian is there, Andes is in South America, Appalachian is in the North America. Appalachians and Rockies are the 2 major mountain ranges in North America. South America, we have Andes that runs parallel to the Chilean coast. So that's it. They are both fold mountains. That's true. And Europe, Alps. Alps is also a fold mountain, not a block mountain. The only block mountain is Vosges. So it is given as fold mountain and it's wrong. It's easy to study actually. Most of the mountains we know are fold mountains only, and only few are block mountains. And study those block mountains and we are done. That's it. See, block mountains. I've put this in a table so that it's easy for you to revise. And I'll explain how they are formed and how they are different. So Vindhyas and Satpuras are one of those block mountains in India. Then Vosges in France, actually not Central Asia. Black Forest, Sierra Nevada, yeah. We have Rockies and Appalachians in North America as fold mountains, and we have Sierra Nevada as a block mountain. Then Vosges, Sierra Nevada, and Rhine. So these four are the block mountains, and rest of them are all fold mountains only. So in India, Vindhyachals and Satpuras are also one such mountain. And how are they formed? Basically formed by compression forces, compression and rising of the sediments or the compressive materials of the plates. So that causes the rising of fold mountains. At the same time, block mountains are caused by faulting. I mean, they are moving like this. A tension is being applied. In these two directions, it is moving. Okay, a plate is being pulled apart, and so it cuts into pieces, and some parts subside, some rises up. This is called strike slip. So this is the reason why block mountains are forming. They are not formed by compression and rising like fold mountains. They are forming because the block mountains are moving up, like a tensional force is there in the plate, and the plate breaks into smaller pieces, and some portions rise up and something falls down, and they are called horse and graben. So they move in this direction. In this direction, this is a tensional force, not a compressive force. It's the exact opposite. It's like pulling a string like this, and compressive force is like pushing something like this. So the tensional force actually breaks apart these plates into smaller faults. There will be fault lines in every plate. So these are the existing fault lines, and due to this push, that they get structured into multiple smaller pieces, and some pull down, others rise up, and the ones that is going down are called grabens, and the ones that is rising up are called the horse. That's it. And in case of, just like I explained, in case of fold mountains, there is this compressional force acting like this. So there will be a wavy structure, anticline and a syncline. Syncline are the trough, and anticline is the crust. So that's it. So they will be having a different structure. Fold mountains will be having a wavy structure, and the block mountains will be having a spherical structure. So that's the thing. And go through these. That's it. Easy thing to remember is very few block mountains are there, major ones. Just learn about them and assume the rest of them as fold mountains. And of course, try to learn where there is Alps, Himalayans, not Himalayan, as we know, Alp, Rockies, Andes, Appalachian, and Sierra Nevada, Rhine Valley, was just where they are located, because these can be asked again also. So that's it. With reference to water vapor, again, like this is the third question I think regarding the whole warming, atmospheric interactions sort of question asking. With reference to water vapor, which of the following statement is or are correct? Okay, it is a gas, the amount of which decreases with altitude. What do you think? Water vapor, we know that it's just water in its gaseous form. So will it increase or decrease with altitude? What do you think? Or it's better to imagine like what's the reason why we have water vapor in the first place? We have water vapor in the first place mainly due to insolation of the sun causing the evaporation of water from the water bodies or whatever water surfaces we have, not just water bodies or oceans, but majorly from them only because of their aerial spread. So that's the major reason. And imagine you boiling a water in a pot, and the water vapor will be accumulating nearer to the pot rather than away from the pot. So that makes perfect sense. So it actually decreases with altitude, because what? Going up, meaning that it's away from the source and it's away from the heat. So it mostly going up, meaning that it cools down and it condenses and it becomes water drops, and the state of the water vapor changes, meaning it becomes water drop. So their amount will decrease. So obvious thing. So this is very straightforward. Imagine just boiling water in a kettle or something, and you can see the water vapor going up to a certain level, and after that you won't even see that because they condense and they fall. And then it's the percentage is maximum at the poles. Is it? Are poles the best place to find water vapor? We might think that okay, it's very cold and it's always like full of water and everywhere, but water vapor needs heat to be remaining in the gaseous state. It's because of the heat that is being given to the water, it remains in the gaseous state. Once it loses that heat, the latent heat, it actually becomes liquid. So you need heat, and is poles the perfect place for finding heat? No, it's definitely no. So that's gone, and this is right. So it's as simple as that. Such a simple questions are asked. If you bringing some examples, analogies in your mind, and you'll easily get the answer. You don't have to study this. You don't have to study that its percentage is maximum at the equator and minimum at the poles. You don't have to study anything. Just use your sense and you'll be easily arriving at the answer. Okay. This is slightly tricky but very interesting to solve question. Logic can be applied here. Okay. Annual daily range of temperatures is low. Okay. Precipitation occurs throughout the year. Wow. And the options are equatorial climate, China type climate. The first two statements perfectly describe equatorial climate. Meaning that annual daily range of temperature is low because sun is always there and the temperature variation between day and night is very low. And precipitation occurs throughout the year. In fact, every day in equatorial climate. So those two statements directly point towards the equatorial climate. So yeah, but the precipitation varies between 50 centimeter and 250 centimeter. That's surprising because this is where having the idea about numbers helps. 50 to 25 centimeters, 250 centimeters, meaning that it's a lower rainfall bracket. But equatorial regions receive more than 500 and receives up to 1000 centimeters of rain annually. So they are not the ones, definitely, because equatorial region receive much almost 4 times more rainfall than this. So they are not the one. But then we have to know about the annual daily range of temperature is low. Okay. Then China type of climate. China climate, if you imagine that it's relatively cold and very less warmth is there. Relatively cooler. Okay. So meaning that annual daily range of temperature between day and night will be much higher. It's not low. It will be higher only. In a cool region, the daytime will be slightly less cooler and slightly warmer, and nights will be extremely cold. So that annual daily range of temperature will be high only. So I don't think China type is the perfect fit for this statement. But fine, we'll move on. Humid subtropical climate. Humid subtropical climate has got a very big issue, and at the same time it kind of makes sense with this one. Because this is somewhat the rain that humid subtropical region receives. Slightly more for humid, but somewhat this is there. But they don't have precipitation throughout the year, and annual daily range of temperature is actually high also there. In a humid subtropical climate, imagine that in desert region also. So that the annual daily range of temperature will be high only. So that is there. Precipitation occurs throughout the year. It's not the case. And the precipitation values are slightly higher for the subtropical climate. So we need something that is having a very moderate range of temperature, or a very moderate climate. As in there are no big variations between day and night. In order to have such a condition where there is a moderating effect, few things are needed. Either it should be along the equator, where there is a moderate effect of climate is there, or it should be closer to the coast. Coast has got a moderating effect. If you can imagine our coastal regions, they more or less have same weather throughout the year. Even in summer or even in winter, they are not as extreme as the regions inside. That's one feature called continentality. So a place which is further away from the coast will have climatic extremes, temperature extremes and weather extremities, because the ocean acts like a moderating factor. Because that specific heat of water and land are different, and this is why there will be a moderating effect. If land gets hotter, the ocean slowly gets hotter. So meaning that there will be a moderating effect. It's like adding cold water to hot water, or adding hot water and a warm water. Eventually the temperature reduces to somewhere in between. That's the basic case here. So there is a moderating effect for oceans across the world, and that is called continentality for the regions that are inside. That's why the interior of India, they have got extreme climates like Delhi, extreme cold climate, extreme cold they get, extreme hot they get. But in coastal states like Kerala, Tamil Nadu, and coastal regions of these states, we have got moderate effect. Just like Goa, the reason why people are attracted to Goa is because of there is not extremities of climate anywhere, or weather for that matter. So this should be the one, because it fits the bill of all of this. As in annual daily range of temperature is low. A west coast coast climate makes sense. Precipitation occurs throughout the year. Okay, it's marine only and it's west coast. So it's possible that it could receive precipitation. And since this is something that we need to be knowing that, okay, this is slightly on the lower side, but we cannot fit this description with anything else. So this is the best bet we have, and we'll choose this. Okay. So that's the answer. Moving on. With reference to Coriolis force, which of the following statement is or are correct? Okay, that's very important part of this, and you need to be knowing few things. It increases with increase in velocity, obviously. What is Coriolis force? If from, imagine two pressure gradient forces. If it's moving away from here to here, usually this should be the direction of wind. But due to Earth's rotation in this axis, the wind actually changes its direction towards that. Okay, so this is this bending of the wind or whatever. It actually applies to water bodies, ocean currents, anything. Okay, so that's because of the rotation of Earth on its axis. So that's called Coriolis force. It's an apparent force. It's not really a real force. It's not like a pressure gradient force. It's an apparent force. In reality, it's moving in straight line only. But with reference to Earth, because we are moving, we might feel like it's slightly bent. That's it. In reality, they are moving straight only. So it's an apparent force due to the relative motion of the Earth on its own axis, rotation of Earth on its axis, and it increases with increase in velocity. That's true. It's maximum at the poles and absent at the equator. Yeah, that's also true, because this bending effect is more pronounced at the poles, and it's less pronounced at the equator. So that's true. So I think we have got that answer also, and I'll explain few things. Coriolis force is just like I said. See, this is ideally how should it go, but due to Coriolis force, it deflects to this direction. And imagine the direction. If it's going from south to north, and the deflection will be towards the right. If it's going from north to south, deflection will be on the left. Okay, this is very important, and understand why this is, because assume that Earth is having consider this part of the hemisphere, northern hemisphere. If somebody is moving from here to here, and Earth has moved this much in that time, meaning that Earth is rotating, somebody is moving from here to here. So once he reaches here, the part somewhat here would be here only. So effectively they have traveled to this much. Okay, that is why the deviation is happening in that direction. And the opposite true for here, because here the radius is less. Earth radius is only this much, and this is longer radius. So when they are traveling from here to here and the bending occurs, they will be traveling to a point that is slightly towards the left. So that's how this left and right changing direction happens. So that's it. Then next question. On June, again, solstice. I think there has been no year in the past we have discussed without having these solstice questions. So it's very UPSC's favorite, I would say. On June 21 every year, which one of the following latitudes experiences sunlight of more than 12 hours? Okay. Here is the thing. June 21. Like I said, you should be remembering when is summer solstice and when is winter solstice and when is equinox. So on June 21, what happens? It's summer solstice, meaning that sun is above the Tropic of Cancer. Meaning, which all latitudes won't have 12 hours, more than 12 hours? Because sun is further towards the north. So the regions in the south won't be having more sunlight. They'll be having less sunlight. So Tropic of Capricorn is gone. You can actually arrive at the answer easily, but I'm trying to say a logic. So this is gone because Tropic of Capricorn is gone. Then we are worried about Tropic of Cancer, Equator and Arctic Circle. So we are stuck between that. Will Equator be getting more sunlight? Equator will be getting the maximum sunlight when it's during the equinox, when it's rightly above the equator. But if it's further away from the equator, whether it's north or south, equator will be getting less sunlight. So equator is also gone. That's gone. Tropic of Capricorn is gone. So we are left with two. Anyways, Tropic of Cancer is there. Yeah, obviously. And Arctic Circle also is there, because Arctic Circle will be getting more sunlight because the sun is more closer to the Arctic Circle than ever. So they will be getting more sunlight also. So that's the answer, 15D. So the latitudes in the northern hemisphere will have more than 12 hours of sunlight during summer solstice, and the exact opposite is true for winter solstice in the southern hemisphere, meaning Antarctic Circle and Tropic of Capricorn will be receiving more than 12 hours of sunlight during winter solstice. That's it. This is the basic thing. Remember the dates, okay? June, December 20 to 22. That's the basic thing for everything. This June for summer solstice, December for winter, and then we have March and September for equinoxes. The vernal equinox in March and the autumnal equinox on September. That's it. Or okay, I told you this question because last year also a question was asked on which among the following countries are part of the Congo Basin. This is why they have repeated the same thing. One of the following reasons are the world's largest tropical peatland. You need to know that fact. The largest tropical peatland is Congo Basin only. That's it. There is no much needed because you might confuse it with Amazon Basin, but it's not. It's the world's largest tropical peatland. It's not asking about the rainforest. It's tropical peatland. So that's Congo Basin. So that's the answer. And UPSC has actually teased us with this on previous year in 2023 by asking which of the following countries are part of the Congo Basin. So this is why going through the PYQs are really helpful. One more thing I'll tell you is try to learn and look up about Kikori Basin and Rio de Plata Basin because sometimes a question can be asked from that also. The same way in the previous years a question on Mozambique was asked and it was repurposed in 2023 also. So things like that could happen. So go through these options and study about them also. Okay. This is strictly logic. You know the answer right away. There is no doubt for that. Which of the following countries are frequently mentioned in the media for their low birth rates or aging population or declining population? Which of the following... Imagine a country that is having a declining population. What kind of country will that be? Or imagine countries with high population. What kind of country would that be? Countries with high population, very less population control, population planning. Things like that are happening in countries or places where there is low socio-economic development, low human development, and low economic development in general. So that's the reason. And higher economic development, with further economic development, the population rate falls, the fertility rate falls, the population growth rate also falls. Things like that happen. This is basic demographic transition, and this is basic for everybody. I think you all know that. This is one reason why poorer countries make more kids, and the countries having higher economic standards, and they will be having fewer kids per parents. So that's one thing. And going by the description, we know that this is something happening in a developed society. So Japan should definitely be there. Okay, in 2 and 4. So meaning South Korea is also there. Okay, then Italy makes a perfect candidate for that. So that's it. And Nigeria, or we could do one more thing. Nigeria doesn't fit the bill. Nigeria is one of the largest populous countries and it's not at all facing any sort of challenges like this. So Nigeria could be eliminated also, and we can easily arrive at the answer. So that's it. So that's about it. I hope the session was useful for you. Try to stick on to the channel. We'll be discussing other topics like environment and ecology. And once all that is done with the PYQs, we'll be moving forward for the masterclass sessions where we'll be discussing the concepts that are difficult concepts, which we will be taking feedbacks from you on which all concepts should be discussed. And with the animations and all, we will be discussing that. So stay tuned and all the best.